In this chapter, we're going to look closely at Hadoop's hardware needs. We'll look at both of the various node types, master and slave nodes, and provide both general and very specific guidance and recommendations on the various types of hardware to use. Growing a cluster is also a very important part of the hardware path, and we'll look at the various ways that clusters grow and how to plan for that. The type of hardware that you're going to purchase depends greatly on whether it's a master node or a slave node that you're purchasing. Master nodes, even in very large clusters, will typically be limited to about 2 to 3 per cluster. Please note that these are single points of failures, or SPOFs. This means that master nodes require redundancy. Specifically, you should look at carrier-class hardware, essentially the best-of-breed hardware that your money can buy. Slave nodes will be many. You'll typically have between 4 to 4,000 per cluster. These are expected to fail and come back into the cluster at any given time. They are not single points of failure. And on these, you want to use commodity-class hardware, or very cost-effective hardware. A good back-of-the-napkin estimate on the cost involved for master and slave nodes is that the master nodes will be very pricey, typically costing you about $10,000 to $20,000 per node. Again, this is carrier-class hardware, and you only have a handful of them. The slave nodes, on the other hand, are probably going to run you between about $1,000 to $3,000 per node. Some organizations might spend as much as $2,000 to $5,000 per node, but definitely not more than that. Looking specifically at the master node hardware, the number one consideration that you want is lots of RAM. The Hadoop daemons that run core Hadoop are very memory hungry. This means that you want at least 24 gigabytes of DDR3 RAM in these machines. Again, the node-level hardware failure for the master nodes is unacceptable. You want multiple RAIDed, mirrored, or RAID-zeroed hard disk. You want hot swappable drives, and you want dual redundant everything. Multiple NIC cards or network interface cards, dual power supplies, so on and so forth. Mid-level CPU is probably acceptable. They're not really CPU intensive, and you can get by with probably dual quad-core 2.6 gigahertz processors. You definitely want at least 2 master machines. This isn't required out of the gate, but highly recommended. We'll see why in other chapters. On the slave node hardware, an administrator is typically going to have one of 2 concerns. They want a high number of disk spindles, and they want to focus on the cost per node. Again, with disk spindles, the more the better. 8 1-terabyte drives, for example, is much better than 4 2-terabyte drives. And again, you don't want super expensive hardware. 7200 RPM disks work perfectly fine. The cost per node is definitely something you're going to want to take into consideration. You don't need redundant anything. Hadoop handles redundancy, both striping and mirroring, at the cluster level. But you want at least 24 gigabytes of RAM in these machines, and probably 1 to 2 quad-core 2.4 gigahertz CPUs at least. Single NIC, single power supply is totally fine. One phenomenon that has come up recently is these Hadoop in-a-rack clusters, such as Oracle's Big Data Appliance solution. These essentially provide very high-end hardware for your Hadoop cluster to run. If you're a big organization and you have a huge budget and the money's going to be spent one way or another, you might investigate getting one of these big clustered rack machines that is Hadoop everything in a rack. Otherwise, a lot of organizations get by just fine building their own cluster out of hardware. On the slave node disks, there's a couple considerations that are very important. You want a JBOD or just a bunch of disk configuration. You absolutely do not want to RAID these machines. Hadoop itself provides a cluster-wide RAID to both replicate and parallel process or stripe both the reads and the writes. You'll see more about this in the Hadoop architecture chapter. You want to aim for having the same storage capacity on each slave. Ideally, you want all of your slaves to be the exact same, but after several upgrade cycles, you'll probably realize that at least the CPU and the RAM will get out of whack. The disks, you want to keep all roughly with the same amount of storage capacity and the same amount of speed. One consideration that a lot of folks miss is that you want an upper limit on the amount of storage per node. An upper limit of 32 terabytes works out pretty good. This essentially makes it so that if a single node goes out and blocks that node was managing need to be re-replicated, it doesn't swamp the entire network, re-replicating tons and tons of blocks. Some general considerations to be aware of is that your slave and master configurations will vary greatly. The storage size of the disks on both the slaves and the master memory will vary greatly depending on your work case, and especially the processing requirements on the slaves will vary greatly as well. Some applications that you use will require a whole lot more memory, and others may need a whole lot more CPU. Out of the gate, you're not really going to know what your applications need with regards to memory and processing, but a good recommendation is to start with about half of your available slots for growth. For example, if you have 4 CPU slots, only populate 2. If you have 8 RAM slots, only populate 4. This lets you find your sweet spot on the slaves and then cookie cutter a base hardware footprint out to other slaves. Network you should consider to be about 20% of your overall budget. 1 gigabit is generally fine for most clusters, but you might find yourself needing 10 gigabits or more for larger clusters. You want to, again, avoid expensive hardware on the slaves and avoid latest and greatest anything. Even when a new version of Hadoop comes out, I would typically let others cut their teeth on the new feature set and wait maybe 3 to 6 months before upgrading your Hadoop version. I highly recommend this book, Hadoop Operations by Eric Sammer. Many of the recommendations that we have in here come from this book, and he provides even better recommendations in a lot of the chapters. Monitoring in Hadoop is incredibly important. When you need to go back and troubleshoot things, it's important to know when your hardware went out of whack. Hardware failures especially need to be found and addressed on this single point of failure master nodes. The slave nodes themselves come and go, but the masters are single points of failure, and you need to address things like network card outages and disk outages as soon as possible on these machines. I highly recommend that you monitor all hardware and software. Disks, you want to monitor for I/O, for failure, for permissions, and so forth. On the network interface cards, you want to monitor for failure and I/O. RAM and CPU usage should also be monitored. It's important to note that disks and network cards especially don't often fail in a binary, hey it's working or hey it's not mode. Oftentimes problems with these specific hardware resources will expose themselves in degraded performance, thus the need to monitor the I/O. The core Hadoop software, the 4 daemons that we see here, the name node, job tracker, and data node and task tracker daemons need to be monitored across every machine. You also want to monitor the memory and the CPU usage and the Java virtual machine details. Cloudera Manager is a product that excels at this. I highly recommend using Cloudera Manager for monitoring your resources, and we actually have a chapter that goes into detail on this. When we talk about the size of a cluster, we're typically referring to the number of slaves. Again, the master nodes will probably be just 2 or 3 per cluster, whereas you may have many slaves in a single cluster. For a small, medium, and large, we typically break it down like this. A small is about 4 to 6 nodes at the start. This is typically when you're in proof of concept or POC mode. At this phase, you may also consider using Amazon's EC2 or Elastic MapReduce. We actually cover setting up a cluster with Amazon's EC2 in the Cloudera Manager chapter. For a medium cluster, this is typically about 20 to 30 nodes. It's important to note that most clusters out there in the world are of this size. Although Hadoop can grow up to very large clusters, about 4,000 nodes for MapReduce version 1, most clusters get by just fine with 20 to 30 nodes. When you get to a large cluster, you may need to upgrade the master hardware or consider things like high availability on the name node and job tracker, which are enabled with CDH4 or Hadoop 2.3. Hadoop uses something called linear horizontal scale to scale out the size of the cluster. Again, we typically start out with just a couple master nodes and a few daemons running on those machines. We may start our cluster out with 2 master nodes and 4 slave nodes, but then we find we need additional processing, so we add an additional 2 slave nodes, and then maybe an additional 2 after that. Now we're up to an 8-node cluster, and we realize that our users are starting to use it heavily. We may want to add an additional 8 nodes here, or an additional 8 nodes after that. We can eventually end up with thousands and thousands of nodes. Again, the upper limit on MapReduce version 1 is about 4,000 nodes. The slave node additions are typically based on either storage needs or processing needs. For example, if our company on the storage side knows that we add about 10 terabytes of raw data per month, and our slave node cookie cutter is about 8 terabytes of raw data each, our default replication factor or our mirroring and our intermediate data, both explained in other chapters, are what chew up this disk space. Replication factor again is our mirroring, and our intermediate data is the output data or tertiary data from the mappers before it gets consumed by the reducers. Intermediate data typically takes up about 20 to 30% of the usable disk space. So although we have 8 terabytes of raw storage, the formula to calculate our usable for storage space is our raw minus our intermediate data divided by our replication factor. In this case, 8 terabytes total minus 2 terabytes for the raw. Let's say that we went with 25% for intermediate data. Overall divided by 3 leaves us with about 2 terabytes of usable disk per node. Again, this is a sort of back-of-the-napkin estimation of our overall disk space, but it typically breaks down into that. For most clusters, with a replication factor of 3, we end up with about a quarter of our overall raw storage space being usable disk space, which in our case means that we'll typically need about 5 to 6 new slaves per month. When you do your CapEx planning on your cluster growth, you could then easily just extrapolate this out over the period of the year and then maybe buy your hardware every quarter in advance of how it's needed. If you're an organization that's growing on the processing side, this typically means that you'll need to be adding more CPU or RAM usage. And again, both of these grow, especially as our concurrent processing needs grow. It's not uncommon to start a Hadoop cluster with maybe only 2 or 3 users, and then once the data is in there and folks are really getting value out of it, find that there's 20, 30, or 100 users who all need to be processing their data concurrently. If you're that type of organization, you'll need to plan out how much CPU and RAM you need to add for the cluster over the next 3 to 6 months. It's important to note that for every slave you add, you're adding not only more storage, but you're also adding more processing capabilities. After you've gone through several upgrade cycles, you'll find out that your cluster typically has a surplus of one or the other. Again, this is where a lot of the ecosystem projects come out of, being able to leverage that surplus of either CPU or storage to let your cluster do more things. Again, in this chapter, we covered Hadoop hardware, the various node types, both general and specific hardware considerations and recommendations, and how to plan for and accommodate cluster growth.